Okay, so we did 2.4 for a few days. Now we're starting 2.5, and a lot of what I love about this unit, as I said before, there's a lot of reviewing. Like we learn something new, and then we'll have an example that's kind of review of something else we did, or it's really closely related, including our calculator skills. So the calculator skills are coming back in a lot of these problems. One of the expectations on the AP exam, as well as the test for this class, is you have to know how to do a bunch of things on these, and that's why we're practicing with these every day. And hopefully, very soon, you'll have your calculators that you can keep at home, so you can practice anytime you want to. All right, so we're going into exponential function context and data modeling, code for word problems. But we've seen a lot of these already, so they're not really that bad. There's only one new problem, our very last example that we're going to do. Okay, so there are many scenarios in the world that can be modeled by exponential functions. Some examples include radioactive decay, population growth, interest on savings, bacteria growth, and many other phenomena that occur in nature. Okay, so lots of different types of word problems we can get. Our first one, Surfside High School was built in 2007 and has a growth rate of 1.8% each year. The initial, important word I'm betting, the initial student population was A sub 0, it's 1,483 students that year. Variable t equals 0 represents 2007, and just a reminder, the rate is always written as a decimal. Okay? So the first thing they want us to do is make a model, write a model to model that information. Okay? And they keep changing up the variables and stuff on us. What you should see there, though, is an exponential function. It's okay that it's not a and b and x and y. I mean, we've seen f of x, we've seen f of n, we've seen all different variables, okay? Bottom line is we have a starting amount, hence a sub 0. That's also our y-intercept if we were graphing it. This is in place of b, and we've seen that before. And t is your time. On a graph, it would be your x value, okay? But b, as I've said before, is either 1 plus or minus r. When you're given the rate, that's not what you plug in. So that's a mistake a lot of people make. They'll say, oh, there's my b value. I'm going to plug that in for b. A percent is always a rate that we change to a decimal 100% of the time. We always change percents to decimals. And then we decide if we're growing or decaying, that would be adding or subtracting from 1. And since this is adding, it would be 1 plus 0.018, known as 1.018. Okay? So we have everything we need to plug into this, right? We need the A value and the B value. Who cares if they gave us those? This would be the model. A sub t equals our initial amount, starting amount, also known as our y-intercept on a graph. And for that reason, this is our b value. So remember, whenever your b is greater than 1, it's showing growth. Less than 1, decay. Right? And then we can use that model to find the population in 2024. So back to the original information, 2007 was the initial year. Now we want to predict in 2024. So even though 2024 is a number, that doesn't give us the number of years that have gone by from 2007 to 2024. So we can just find the difference. So t is 17. So all I'm going to do is plug t into the spot for t in my calculator, and let's see what we get. So 1483, parentheses, 1.018. Close my parentheses to the power of 17. So just type it in, enter, and use some common sense here. We're talking about students, people, right? So we don't have a decimal number of people. Let's use our normal rounding rules and say that that 4 tells the 8 to stay the same. So we have approximately 2,008 students 17 years after. Does my answer make sense? Always ask yourself that. We started with 1483. We're growing 17 years later. Good. Because a really common mistake on these types of problems, like I don't think any of you thought that was difficult, right? It's not difficult. There's just a lot of little places you could make mistakes. One of the major ones, like I said, is plugging R in place of B. Okay, R is not B, R is R. Okay, and if you did that, you might just have 0.018. Your answer would not make sense. It'd be a very small number. So that's one way of kind of catching a mistake, is making sure, is this answer make sense? And it does. Okay, you good on that one? Yeah? Okay, look at this next little blurb in here. They give us a kind of a new equation. It's still exponential. It's got something added into it. So this is a population question, initial side p sub 0. Okay, call it anything you want, but that sub 0, it's telling me one thing. But that's like my traditional A, or starting amount, my y-intercept, all the different things we've been calling it. T is if you're doubling something, right? Multiply by 2, it's growth. And it's got T over K. So what K is, K and T are both time, okay? But K is how often you double. So I've tried to think of a good way of like explaining K, and I will do a better job of it when we have an actual example. But K answers the question of how often, okay? And that's not very mathy, it's not very mathy, but it makes sense when we talk about this question. Okay, so I'll come back to that K thing. And in this example, like, I just want you guys to know, when I read a word problem, and I'm a professional math, when I read a word problem, I am almost like deflated. I don't enjoy word problems either. So I like to pass on things that help me. And one of the things is, I sometimes read a word problem and my mind glazes over. I'm like, what is it saying? And a really good part of a word problem to focus in on, well, two things. What formula am I using? And what do they want me to find? What's the variable that's missing that I have to find? And so if I read this, a certain fish species was introduced into a tidal basin 10 months ago. I'm being real professional, right? I'm underlining important stuff, even though I might not know what's going on right now. The current fish, I like that word, current fish population is estimated to be 220, doubling every 5 months. Okay, so let's see. Why do I underline this stuff? Well, what are they asking us to find? Find the initial size. That's super helpful. That means none of the information they gave me is which one of these variables. Which one am I trying to find, in other words? P sub 0, right? That's my initial population. So that kind of gets that out of the way. So in all that stuff that I underlined, I should be able to fill in the rest of it. That's one way of doing it. So so that must mean if I don't have P sub 0, I must have P of T. And I do. T is 10 months. Okay, let's talk about that. And the K is how often do we double? So let me go back. P is 2, right? Doubling, we double every, how often? How often do we double? Every 5 months. So the question is, if I just asked you this, how many times does our population double in a 10-month period? Twice, right? Every 5 months we double. That's why we have to have the divided by K, all right? So that leaves one variable, by the way. That leaves P of T, which is P of 10. That's the total after 10 months. The question is, how much do we have now? How much did we have when it started? We know how much 10 months later we had, but how much did we have when it started? So let's just plug into the equation. I'm just going to use our algebra skills to solve for the unknown variable. So that's 220 equals what we don't know times 2 to the power of 10 months, doubling every 5. So, of course, 10 over 5 is 2. 10 over 5 is 2. So that's 2 to the second power, or 4. It looks weird, but this is just a variable. It's the same as saying x times 4 or 4x. To get that variable by itself, I would divide both sides by 4, and I get my initial population is 55 fish. Does my answer make sense? Start with 55, 10 months later, 220. Yeah, it does. I'm getting bigger. Doubling is going to be growth, right? Getting bigger. estimate the population of the fish 1 year. So T is what we need to plug in. So we have a model now. We have the model P of T equals the initial amount, now we know it, doubling. We can plug in any T, and then we have that 5 there. Okay. So T, what would 1 year be? 12. Be careful, right? Common mistake there would be to plug in a 1 year, but K and T have to have the same measure of time. So you either have to change them both to year or both to months. Obviously, it's easier to make T 12 or 1 year. And then to your calculator. 55 times 2 to the power of 12 divided by 5. Typed it right in my calculator, hit enter, and that would be approximately 290 fish. Does that make sense? Yes. At 10 months, we were at 220. At 12 months with growth, we're at 290. The answer makes sense. Think of how many multiple choice questions you could eliminate some choices by the answer just not making sense. Be smart test takers on top of smart math people. Good on that one? Yeah? 2 more. One more word problem like this, similar to all the other ones. Instead of being doubling, it's half. And we've already talked about half-life. That means it cuts in half. That's decay. So suppose the half-life of a certain blah, blah, blah is 40 days, and there are 8 grams present initially. That word is really, really common. Okay, initially, thank you. All right, find the time, right there, find the time, that there is 1 gram of the substance remaining. All right, so they gave us this little setup. We could have used the one we just used in the last one. It doesn't matter, right? We have A sub T equals the initial amount. They gave us that, 8. Half-life is always going to be 1/2. What's this business? Okay, you want to be technical about it. It's 1 minus whatever our rate is, which is 0.5 or 1/2, right? We didn't need a formula for that. A half-life means B is 1/2. Doubling, B is 2. We don't need a formula for it, okay? And then time, what we're trying to find, what we need to know is K. How often do we get cut in half? How often? Every 40 days. So K is 40. Okay? So the question is, the question is, when this is 1, you don't really have to write this, what is T? Okay? And think of it. It's basically saying, what is X when Y is 1? Right? This is my Y value. This is my X value in terms of regular old algebra or a graph. Okay? So let's start. So this is really good review of some calculator skills. Okay? Let's clear our RAM and enter it into Y equals. Let's see what this graph looks like and talk about different things we can do. 8 times 0.5. This is the type of problem that you could definitely encounter on my test, on the AP test, where you have to know how to do the steps. Like, where I'm not going to say, oh, you go here, you go there. So practicing it with me is really important, okay? You don't want to just watch me. You want to be able to press the buttons all by yourself. Okay, so there's the equation. Let's hit graph. And if you hit graph, it doesn't look like a whole lot. So your first reaction might be, wait a second, did I do something wrong? And the answer is you didn't. You didn't do anything wrong. We're just really zoomed in. Remember, your calculator defaults to windows in every direction of 10. 10, 10, 10, 10, 10. So we know, though, if I had to sketch it, it's decay, right? I'm going to hit the x-axis at 8, wherever that is. But it's going to look something like that. And I want to know where x is 1, so I'm going to actually use my intersection. I only need quadrant 1. So, but somebody asked me earlier, so let me just address this. Why can't I use my table? You said, and it's true, I said if you need if you have x, If you need x and you have y, we could go to our table and find it. It's there. We could scroll through till we get to 1. Just keep going, and the number of x values are getting bigger and bigger and bigger, which makes sense. But I'm going to give you a little heads up that you wouldn't normally know, of course, but I have the key, so I know it. T is actually 120. So you would actually be sitting here and scrolling all the way down to 120. Now, if it was a multiple choice question, of course you could try all the different numbers by changing your table and all that stuff. But being able to find the intersection is another skill that we need. So let's go back to y equals, and I'm going to put in y equals 1. Remember, this is a really clever way that it's going to put the 1 on there, and it's going to show where they intersect. So that point is what we're looking for, comma, 1. But remember the problem with our graph? It's not very good. I can tell where it's going to happen, way to the right somewhere, and there's a lot of space here. So I'm going to have to really fix my window. I don't really need the other quadrants. I don't need to the left of x. You can change that or not. Like, I think I just changed it to -5. I moved it over a little. But that's optional. You don't have to do that. It's the x max that I want to change. Now remember, I don't know t is 120 going into this. So I might pick a big number like 100 because I can see it's pretty far down there by how much space is on between those two. So let's just play with this for a second. And y minimum, maybe I'll just make it a little smaller. And you could even change y max because we only need to see up to 1. So if you really want to zoom in nicely, you could really play with these numbers. There's no like set 100% way it has to be done like this. We could all have different numbers in here and still get the same answer. I'm just kind of playing with it with you. So when I graph, okay, I'm getting a little closer to the area line. Now I can see that curve of the exponential function. And I'm getting closer, but I'm still not hitting the intersection point. We know it's 120, all right? But we pretend we don't know that. I might say, I'm over this. I'm sick of changing it. I'm just going to jump all the way to 200, okay? And you could have done 150. You could have probably done 130. A lot of different numbers would work. Understand this. It does not have to be perfect. You just have to know roughly, truly, roughly where they cross. I did a pretty good job with this one. Not every class I did. I changed the numbers up. As long as I know really in a general area where they touch, that's all I need. Because we have well, let's do it. So we're going to go to calc. So that's second calc. Calc means calculate. Calculate a zero, a minimum, a max, or an intersection. And it gives you a fun little blinking cursor that's already to the left of the intersection. It doesn't matter where you are to the left of it. If you think you're too close because you're not sure, you can go further away. You can get closer to it if you're comfortable. There's a big zone in here that you could hit enter as long as you're to the left of it. So I hit enter. Then you use your right arrow, go past it a little bit or a lot. Look, I'm going to be really safe and go way over here. I'm way to the right of the intersection, and I hit enter. And then remember, you have to ask it to guess. Enter, and you can see I get x is 120 when y is 1. That's the ordered pair that my cursor is on. And that's why our answer, told you, was 120 days. It would take 120 days for us to get down to 1 gram. Okay? So being able to find the intersection is a skill you guys need to know. But you can see it's not bad. It's not. You don't even have to have a perfect graph. You have to have the intersection on your screen. Okay? Any questions on that one before we do our final example? Okay, so I always talk about like in different types of math, like I kind of think of the world as algebra-based, geometry-based, although that's very general. I'm an algebra girl. I get algebra. I love how clean it is, and you do all these steps and all these rules, and it's just nice and clean. You end up with x equals 5 or something. Geometry is, I hate it. I just dislike it. Okay, this is a problem for my algebra people. Okay, this is some fancy algebra that we're about to do. This has got a few steps involved in it, and you do have to know how to do it by hand, like we're going to do, and I gave you one in your homework. Okay, so what we're doing here is we are given an exponential function, the graph, and we need to write the equation. We're going to write the equation for it. So we know, we recognize it. Oh, that's an exponential function. Here's like a nice simple version of it, right? I need the two variables, A and B, out of this graph. Wait, A is the y-intercept. But if you look really closely at your notes, our y-intercept is in between like 2 and 3. It didn't label it for us. Sometimes we get lucky and they give us the y-intercept, and then we only have to find one variable. But in this problem, it doesn't give us the y-intercept. We have nothing except 2 points. Here they are written here, okay? So we have 2 points. That's very valuable. Those 2 points represent these variables, x and y, right? They're just ordered pairs. So what I'm going to do is I'm going to plug x and y into this equation, right? I'm going to put y here and x here. And I'm just going to plug into this one. Do it first. So 12 equals a times b to the negative 5. And I think even in our math relationship together, I've said many times, you can solve any equation algebraically as long as you have all but one variable, right? But we still kind of have a problem here because there's 2 variables. So this is where the fancy part of our algebra comes in. Let's see what we can do with this. I have 12 equals. Now, when you have a negative exponent, remember, you can cross the fraction bar to make it positive. How about we go one step further and get a by itself? Algebra, opposite division, multiplication. And I get a equals 12b to the 5th. Okay, Ms. Morris, how does that help me? It's still not a. But watch this. Now I'm going to plug my other point into this, just like I did with this first green one. So instead of 1/2, I'm going to use 0.5. It's just easier. I still don't have A. I still don't have B. And then X would be 6. Okay? I'm just plugging these 2 points, Y and X. There's got to be a reason I had to do this. And that is, I can take this A and plug it in for this A. Why is that a smart thing to do? What does that do for me? Come on, Izzy. Yeah, we get down to one variable, right? If I substitute 12b to the 5th for A, and then I still have b to the 6th, I now only have one variable in here. And the reason we're allowed to do this is because they're points on the same graph, okay? So I can now solve for b to the 5th times b to the 6th. Add your exponents. And we're going to solve for b. More fancy algebra. Good thing we have a calculator. Divide by 12. So 0.5 divided by 12. 0.5 divided by 12 gives you a yucky number. So we hit math, enter, enter, better number. But that's still not b. Could it be that we have to do this kind of math? What would we do here to get b by itself? Square root. So guess what? We're going to do the 11th root of b to the 11th. Because if I do the 11th root of b to the 11th, guess what? I'm left with b. But I have to do it to the other side. And again, this is a calculator problem. How do we do square roots, cube roots, any root? Well, you can go to math. If you look at math, number 5 has a x there. You just have to put the root on your screen first. So 11, math, 5. And you can see on your screen now you have the 11th root. It puts it right in there for us. We let our calculator deal with this weird problem. 1 divided by 24, 1/24. And you're going to get a decimal. We finally have half of our answer. B equals 0.749. Now we need A. You have choices. It's kind of like when you work with a system. You have choices. You can plug it back in anywhere. You can go back up to either of these or the cleaned up version of that one, which is a lot friendlier, right? If you just plug in B right there, you'll solve for A after you multiply. So that's what I'm going to do. I'm going to plug into that one. But any of them would work. 12 times 0.749 to the power of 5. Plug it right in. And we get 2.829. Does that make sense? Yeah. Remember, our y-intercept was somewhere between 2 and 3. We couldn't pinpoint it because of that. It's a decimal, all right? It's an irrational number. And so our final answer is 2.829, that's my y-intercept, times my decay rate, which makes sense. We're getting smaller, so we should be less than 1 to the x. Okay? So in number 10, they give you the y-intercept. Number 12, they do not. So you can cut down on half of your work on number 10. Okay, what is the y-intercept of that? It's not a trick question, it's just repeating something I just said. Yeah, your y-intercept is your a value. In word problems, it's your initial amount. On a graph, it's your y-intercept. So 0, 2.82. Right. A is your y-intercept. Okay, that's it. 1, number 12. So go to practice set 2 and I'll give you the assignment. Most of these are really quick and easy. We have a work day coming up on Wednesday, which will be our next homework check. Next Wednesday will be a work day, catch-up day. You won't have a quiz to work on. You can work on just homework. All right. So practice set 1. So I changed the assignment earlier today. So I usually circle the problems that you're going to do. I circled a whole bunch of problems that you don't have to do because I changed the assignment. So don't go by what I circled. Go by what I wrote here. Just do these problems. So you circle them on your paper if you want to. There's plenty more there. The ones I didn't assign are still good problems. So if you felt like you needed more practice, those are really great problems. And the key to the whole thing is on Canvas, but you don't have to do them all. Okay? Just these. Everybody have it written down? Ashton? I'll come over to you in a second. I'm so sorry. It takes me so long to read that. got your quiz done for tonight. You haven't submitted yet. You finish it, but didn't submit it, it'll submit for you. Oh, the recording works.